Okay, here's a wild thought for you. What if your feelings, your thoughts, what if they had a shape? And I don't mean that metaphorically. I mean a real, actual geometric structure that we could map out. It sounds like something straight out of science fiction, but a really groundbreaking new theory suggests it's a scientific reality we're just starting to wrap our heads around.
I mean, really think about it for a second. What is the shape of a feeling or a memory? What's the geometry of experiencing the color red? It seems like an impossible, almost poetic question. But what if it's not? What if our entire inner world, everything we've ever experienced, has a hidden geometric structure just waiting to be discovered? Well, a brand new framework, and it's got a big name, the Phenomenal Manifold Hypothesis. It proposes exactly that. It suggests that this isn't just philosophy. We can actually use the universal language of math to create a formal map of conscious experience itself.
So that's what we're diving into today. We're going to go on a little journey to understand this incredible idea. This is the story of how you can, in theory, draw a map of the mind using the brain's own information as our compass.
Okay, first things first. Why on earth would we even think our inner world has a shape? It sounds pretty out there, right? But when you break it down, the reasoning is actually surprisingly intuitive. It really boils down to three main ideas. First, our experiences, they already kind of have geometric properties. Just think about it, right? The color orange feels closer to red than it does to blue. Sadness isn't a million miles away from melancholy, see? These are relationships, they're distances, and that is the language of geometry. Second, we know for a fact that specific patterns of information in the brain line up with specific conscious states. That's a huge clue. And third, we've got all these theories of consciousness, but they mostly talk about the brain's plumbing, None of them give us an actual formal map of the experience itself. This theory, this one wants to finally draw that map.
All right, so if you're going to build a map of anything, you need a way to measure the terrain. So before we can even start sketching out this mind map, we got to figure out what key features of the brain's information we need to measure.
And this is where the theory gets specific. It says we can chart this whole inner world by measuring just three fundamental properties of the brain's information. These are like our x, y, and z coordinates for the mind. Let's take a look at the first one.
First step is integration, which you'll often see written as the Greek letter phi. This basically asks, how unified is this whole experience? When you watch a movie, you're not just seeing separate pixels and hearing separate sounds. It's one single seamless experience. The analogy here is perfect. Integration is what makes a piece of fabric, all woven together, different from just a pile of loose threads. High integration means the whole is way, way more than the sum of its parts.
Okay, next we have coherence, or gamma. This one's all about synchronization. It's a measure of how in sync the brain's activity is across huge areas. Picture a giant stadium full of fans. If they're all clapping at random, that's super low coherence. But if they all start clapping together in perfect rhythm, that's high coherence. It's like the brain's internal rhythm section.
And our third and final measurement is differentiation, or delta. Now, this is all about richness, diversity, and complexity. It's basically asking, how many different states can the brain be in? The painter's palette is a great way to think about this. A brain with high differentiation is like an artist with millions of distinct colors to work with. It can create these incredibly vivid, detailed pictures. A brain with low differentiation, that's like being stuck with just black and white. All right, so we've got our three ingredients: integration, coherence, and differentiation. Now we get to the really cool part. How do we take these measurements and actually build the map? This is where it all comes together. And this leads us to the absolute core idea of this whole thing, and it's a beautiful one: the phenomenal manifold. So, what is it? It's a geometric space where every single point represents one unique, possible conscious experience. Every feeling you've ever had, every thought, every sensation, it has its own unique address, its own coordinate in this incredible space. Here's a good way to picture it. The raw information firing around in your brain at any given second is like a huge, impossibly messy mountain range. There's just too much detail, too much static. The phenomenal manifold is like a simplified, clean, topographic map of that range. It filters out all the noise and just shows you the important features, the ones that actually create your conscious experience. Okay, so how do you literally draw this map? It's a three-step process, and it's pretty elegant. Step 1. At any given moment, you measure the brain's unique information signature. That's its specific mix of integration, coherence, and differentiation. Step 2, a mathematical rule takes that signature and plots it as a single point in a geometric space.
And step 3, the collection of every possible point for every possible signature, well, that creates the complete map. That is the phenomenal manifold.
A map's no good if you can't use it to get around, right? So let's take our new mind map for a spin and see if we can find some familiar places, like different states of consciousness. Okay, now this is where the theory really starts to get exciting. This table shows how different states of mind literally create different shapes on our map. So let's start with just normal, everyday waking consciousness. You've got high integration, moderate coherence, and that gives you a complex, high-dimensional, rich geometry. Now compare that to deep, dreamless sleep. Everything just plummets, low integration, low coherence, and the geometry basically collapses on itself into what they call a degenerate structure. It just flattens out. But look at psychedelic states. This is wild. They can actually expand the volume of the map, creating these high curvature regions. Think of it like adding new, weird twists and folds to the landscape of your mind. And then some meditative states can do the exact opposite, shrinking the map down to a very simple, low-dimensional and serene shape. So here's the big takeaway. Different states of mind aren't just these vague feelings. They are distinct, measurable, geometric shapes. Your normal waking consciousness is like a huge, sprawling, complex city on this map. And that deep, dreamless sleep, it's like that entire city just collapses down into a single, tiny point. All right, last section. Is this map real? Look, this is an absolutely beautiful, elegant idea. But we have to ask the big question. Is it actually science? How do we know if this map is describing reality or if it's just a cool thought experiment? Because a beautiful idea is just not enough in science. For a theory to be taken seriously, it has to make specific, testable predictions. Predictions that you can go out and check in a lab, and crucially, predictions that could be proven wrong. That's what we call falsifiable. And this is where the theory does something really, really clever. A potential weak spot for an idea like this is the whole concept of dimensions. I mean, how many dimensions does consciousness even have? A weak theory would just kind of fudge it, right? It'd say, we'll just guess a number that works. But this theory makes a much stronger, bolder claim. It says the number of dimensions isn't something we just make up. It's something we can actually measure directly from the brain's data. So it takes what could be a weakness and turns it into a testable, falsifiable prediction. And get this, it doesn't just stop there. The theory makes a concrete number-on-the-board prediction. Based on how complex our normal experience is, it predicts that the geometry of waking consciousness has somewhere between 8 and 15 dimensions. Now that is a number that neuroscientists can actually go out and look for. If they run the experiments and consistently find, 3 dimensions or 50 dimensions, then the theory's in big trouble. And that's what makes it real science. And that really brings us to the final thought here. For centuries, we've been exploring the world around us, drawing these amazing maps of continents and star systems. Now it feels like science is finally turning that lens inward, trying to draw the first real maps of our own minds. And if we can actually do it, this is so much more than just an academic game. I mean, imagine having a map to navigate mental illness, or a blueprint to help create artificial consciousness. So the question to leave you with is this. If we can truly finally map the mind, what incredible new territories are we going to discover inside ourselves?